Space is big, really big, and getting to interesting places in space requires a lot of fuel, or does it? Space telescopes like the James Webb Space Telescope seem to defy this rule, traveling vast distances without carrying massive fuel tanks. How do they do it? The answer lies in a clever combination of physics and orbital mechanics. Imagine throwing a baseball. On Earth, the ball eventually falls back down due to gravity and air resistance. But in space, there's almost no air to slow it down. The ball would keep moving in a straight line forever unless acted upon by another force. This is the principle of inertia, and it's key to understanding how spacecraft move. Space telescopes use this principle to their advantage. A powerful rocket provides the initial push to escape Earth's gravity. Once in space, with minimal friction to slow them down, they can coast for incredibly long distances using very little fuel. The concept of momentum is crucial here. Momentum is a measure of an object's motion and is directly related to its mass and velocity. The faster an object moves and the heavier it is, the more momentum it has. Think of a bowling ball rolling down a lane. It has significant momentum because of its mass and speed. To stop it, you need a force acting in the opposite direction. In space, however, there's very little to slow down a spacecraft once it's in motion. This means that even small bursts of thrust, strategically timed, can have a big impact on a spacecraft's trajectory. Like a gentle nudge to the bowling ball, these small adjustments help fine-tune the telescope's path, sending it toward its distant destination. But what about staying in one place? For telescopes like the James Webb Space Telescope, which need to maintain a stable position for long periods, scientists have found a clever solution: Lagrange points. Imagine a cosmic dance between the Earth and the Sun. Their gravitational forces create 5 special points where the pull from both bodies balances perfectly. These are the Lagrange points. The James Webb Space Telescope resides at Lagrange point 2, about 1 million miles from Earth. At this sweet spot, the telescope can orbit the Sun in sync with Earth, using minimal fuel to maintain its position. It's like being in a slow cosmic dance, perfectly balanced between the gravitational forces of the Earth and the Sun. Looking to the future, we find even more ingenious ways to traverse the cosmos without relying on traditional fuel. One such technology utilizes the very force that powers our planet's sunlight. Believe it or not, light itself can push objects, a phenomenon known as solar pressure. While the force is minuscule, it's ever-present. Over time, this gentle pressure from photons can accelerate a spacecraft to remarkable speeds. Imagine a spacecraft unfurling giant reflective sails, much like a ship catching the wind. These solar sails would harness the momentum of sunlight, propelling the spacecraft across the cosmos without the need for heavy fuel tanks. The potential of solar sails is immense. They could enable missions to distant stars and planets, venturing far beyond our current reach. As we continue to explore the universe, embracing innovative technologies like this will be crucial to unlocking the secrets of the cosmos.